Good afternoon, this is Schweitzer, and we are looking at another question here is, can I determine the pH of a strong acid? This is typically our second major quiz topic. Can I determine the pH of a strong acid? In the last video we talked about the idea of completion versus equilibrium. Now, you should be aware that a strong acid, and we will be doing lots of examples of this, is an acid that goes to completion. Or it goes through hydrolysis 100%. Someone might describe that as 100% ionized. So, in this case, if we have, let's say, a 0.1 molar concentration of HCl, and HCl plus water yields H3O plus Cl negative. Initial stoichiometric ratio end. 0.1 is my initial concentration. Water's not being tracked. And then it is an excess, I guess you could say. Nothing to begin with, and then I have minus 0.1 plus 0.1 plus 0.1, which gives me 0.1, 0.1, and 0. In this case, I go 100% to product, and in this situation, let's draw a picture of it. A strong acid, therefore, I just want to draw literally what is at the end. I have no HCl's. All I have is H3O plus Cl minus. How many of these I draw would just be proportional to the 0.1. So if I have a 1 molar, I'd be just drawing more of them. H3O plus and Cl minus. Keep in mind, your quantities of your cation and your anion must always be equal. Now, because every strong acid, now let's list out the strong acids. These are something that, once again, you good note card material. But strong acids, the way we know if a strong acid is strong or not is by listing it, looking at this list. If you come across an acid that's not on this list, then it's going to be considered weak. So weak acids go to equilibrium. Strong acids go to completion. Strong acid, HCl. Hydrochloric acid. HBr, HI. This is hydrobromic acid. Hydroiodic acid. HNO3, H2SO4, HClO4. Probably the least common of all these guys is perchloric acid. It's also a strong oxidizer, which makes it very dangerous. So you don't find it around as much. Alright, this guy is nitric acid. All of these guys, honestly, are all strong oxidizers. Because they have oxygen, they can give it away and cause things to burn. This is sulfuric acid, and then we have called perchloric acid. Okay, perchloric acid. Now, those are my acids. If you come across an acid that's not on this list, let's say HF. HF is, in the movies and other things, is commonly deemed being very dangerous. Is it dangerous because of its acidic properties? No. It's dangerous for other reasons, chemically. Just very poisonous. Alright, in this sense, we have strong acids. Doesn't matter which one of these I use, it goes 100% to completion. So, what if our overall goal here is, what is the pH of an acid? Well, in this last case, what you do is an acid is determined by the concentration of the H3O plus ions. So I take this number and I just go the negative log of the concentration of 0.1. And if you remember, or if you've had a chance to work with this a little bit, negative log 0.1 is just 1. So my pH is 1. Unusual. There we go. The pH is 1. So let's do another one. Let's pick a different acid. Let's do nitric acid. HNO3 plus H2O yields H3O plus NO3 minus. Okay, let's do 0.5 molar concentration. So initial stoichiometric ratio end 0.5 molar concentration, not playing a role. 0, 0, minus 0.5, plus 0.5, plus 0.5, 0, plus 0.5, plus 0.5. This is my ending situation. And the beaker would look very much like the last one. The ending beaker would have only products in it. H3O plus, NO3 minus. These are typical pictures of strong acids. The negative log of this guy, negative log of 0.5 equals, in this case, keep in mind, a 1 molar concentration gives me a pH of 1. A 0. Up, and I got a little point there. I didn't mean to put a point there. So 1 molar. 0.1 is 1. 0.01 is 2. So I'm somewhere between here. 0.5. And the pH, because it's not linear, ends up being negative log 0.5 is 0.3. Should fit right between there, though. Okay. So strong acids always go to completion. So without writing all this stuff down, okay, a student might just say, for strong acids, I'm just going to take the concentration of my acid and plug it into this formula. And very common, this does work. 0.15 molar concentration of HI. All you got to do is take the negative log of 0.15 and I get my pH. Alright, so negative log 0.15 and it gives me 0.82 in the pH scale. Alright, so this is getting close to one of our first skills that we want to be able to test on a quiz, and therefore you should be ready for a quiz coming up here pretty quick. Thank you very much.